Hi, calculus kids. This is Dr. Callahan with week 15 Thursday. How are you guys doing? I hope you guys are having a good week. So go ahead and take a look at the warm up right here. There are 3 questions. So pause the video for week 15 Thursday and answer the following questions. All right, so let's go over the 3 different methods of finding limits as x approaches infinity, and there are 3 of them. The first one is simply just you go ahead and remember the 3 rules for horizontal asymptote. Remember, if the exponent on top is smaller than the denominator, then your horizontal asymptote is going to be a 0 as x approaches infinity. On the other hand, if the top has a bigger exponent than the denominator, then it does not exist, or it could be a positive infinity or a negative infinity, depending on the work that you're doing. If it's positive infinity, the reason why it does not exist is because you can't definitively put a number on infinity. I mean, it's a really big number, but we just don't know what it is. And then lastly, if the exponents are exactly the same, then you just take the coefficient in the front. And so in this case, it will just be 4/2, which is your horizontal asymptote is going to be 2 as x approaches infinity. Second method of going ahead and finding as x approaches infinity is going to be with the dividing of the biggest exponent. So you take the highest exponent on the numerator or denominator, and then you're going to divide everything, all the terms with that, and then you're going to start canceling. Now, the last one is by L'Hopital's rules, which we talked about a few days ago, and you're going to be using the first, second, and sometimes maybe even third derivative when you plug x approaches infinity. As long as it doesn't end up with infinity divided by infinity, then you can go ahead and stop and figure out what the answer is from there. So I have 3 different examples right here. So go ahead and take a look at these 3 examples. If we're to use the 3 rules for the horizontal asymptote, it's pretty easy to see what the answer is, because if you take a look at A, here you have the exponent of 1, exponent of 3, so obviously the numerator is smaller, so your horizontal asymptote is 0. Here they're exactly the same. Sometimes they're a little bit mixed match, but just make sure you find the biggest exponent here. So in this case, it's going to be a -2 divided by 3. And here the numerator is greater than the numerator, so it just does not exist. Now, on the other hand, if I use a second method, which is to divide the top and bottom by the highest exponent, what would you see happening here? How would I be able to get the same answers of 0, -2/3, and does not exist if I were to do that? So take a moment and reflect on that. All right, let's take a look over here on the first one. If I were to go ahead and divide everything by x over 3, or x to the 3rd power, then here, if you look at it, when you have a small number over like something like infinity or infinity squared, essentially this is just going to become 0. So this is going to become 0. 2 times infinity over infinity to the 3rd power. It's still, I mean, you could cancel it, which is a -2 over x squared. If you plug in infinity, it still becomes a 0. And then at this point, it doesn't even matter what happens in the denominator, because the numerator is 0. You can go ahead and continue on working on this. That cancels. This becomes a 0. So you have 0 minus 0 over 3 minus 0, which is just 0. And check, that's exactly the same answer that you received when you use the 3 rules. Same thing with the second one over here. If you divide top and bottom by x, I have 3 divided by infinity, which is going to be 0. So you have a -2. Then here, that becomes a 0. Then what ends up happening is 0 minus 2. 3 minus 0 is just y equals -2 over 3rd, over 3, which is exactly what you have before using the 3 rules. Last one, biggest exponent is x squared. So I'm going to divide everything by x squared. This is going to become a 0. You have a 2, -2 in the numerator. Here it's going to become 0. This one's become 0. This one does not exist because you can have a -2 over 0, which is just undefined. So therefore it does not exist. And then of course you can use L'Hopital's rules for this as well. So let's go and apply it to B over here. So first you want to do direct substitution. If I were to substitute every x with the infinity, 3 minus 2 times infinity over 3 times infinity minus 1. it's just going to give you a negative infinity over 3 times infinity minus 1 is just going to be infinity. So in this case, it's not a specific answer. So you would have to use L'Hopital's rules, which is finding the derivative of the numerator and the derivative of the denominator. So that's going to give you a -2. That's a 3. Put it back over here. You will have a -2 over 3. And guess what? That is actually your answer as well. So that's how you will use L'Hopital's rule. On the other hand, let's try this one here with L'Hopital's rules. So if I were to plug in infinity here, you'll see it's 2 times infinity squared over 3 times infinity. So it's just infinity over infinity. If I find the derivative of the numerator and the derivative of the denominator, I will have a -4x over 3. And so as I apply the limit x approaches infinity with -4x over 3, what's going to end up happening is if I use direct substitution, 4 times infinity is going to be a really, really big number. And as we go further and further along, 3 essentially becomes a very small number. So eventually what's going to end up happening is you'll just have this over 0. So in which case it will be undefined. Or if you think about it, if you have like a really big number such as, let's say, 1,000,000, divided by a very small number, like this 3 is going to get smaller and smaller. So let's say divide by 0,001. What's going to happen? You're going to have a super duper big number on top. Or we can just say it is just infinity, in which case infinity is the same thing as does not exist. Okay, and that is your answer for that. All right, so let's go ahead and take a look at your guided notes for today. If you go ahead and take a look at, I know it's week 15 Thursday, but this one is actually going to be on week 14 Friday. So in your guided notes, you should have this on week 14 Friday. So turn over to the week 14 Friday notes. Before I move any further, I want to make sure I talk to you guys about your guided notes for week 16, 17, and 18 because I wasn't expecting us to leave at Tuesday. I thought we had at least this week to kind of go over things, but apparently we didn't. Your guided notes is almost here. They're going to be delivered on Thursday. And so if you would like to have a copy of it, you can come over to B1 and just grab a copy of it. I'm going to leave it outside the door on a table and I'll label it calculus. And so if you need a hard copy, you can do that. Now, on the other hand, if you would prefer not to do that, I can go ahead and upload a hard copy of this here, which I believe I did. Yes, I did. It says, hi, here are the guided notes for week 16, 17, 18 to the end of the semester. Just go ahead and click on that. You can go ahead and print it out at home if you have a working printer. And it basically looks like this. There is really just one more section of things that we need to talk about before the final, which is on optimization, which is not exactly the easiest. I would say it's about similar to like related rates as well. But this is your guided notes starting on week 16 Monday, Tuesday, and if you scroll down, it goes all the way to week. It goes all the way down to week 18 Friday. So this is everything here. Now, some of you guys have asked for study guides and whatnot. And if you take a look at the very end of some of these questions, these are some of the calculus AB stuff that you must know. And these are some of the cheat sheets that I've included for you guys. You're welcome to use this on your final. All the work that you've done, all the guided notes is fair game on it. So you're welcome to do that. But if you go ahead and take a look, it says day 9 final review packet. This is for week 18, fall semester 1 Thursday. This is part of your study guide. So if you want to go ahead and just jump into it, that's completely fine. And if you scroll up, there's just more study materials here, and it says AB fall exam review. There's several of them. Also, week 18 Friday, you have your warm-up block due. So I actually included this right here so we can get that done in class. But yeah, as we get closer to it, you'll have that. But for those of you guys who are asking about study guides, these are the study guides. You have them in this packet. You can either print it at home or, like I said, you can come over here and pick it up in person. Entirely up to you. Personally, it doesn't matter with me how you guys want to do this. So yeah. And all the cheat sheets that you have, all the things that you need for this class is right here. All right, so with that said, let's go ahead and go back to this, to today's lesson. All right, so if you go to week 14 Friday, you'll have this in your notes. And if you take a look at this is the steps and works for finding limits at infinity. I have several examples over here, so I would just recommend that you guys read it. And then afterwards, you have some of the textbook questions from the guided notes itself. And we're going to go over this briefly today as well. And then you have a calculus puzzle. It says, why was a polynomial afraid of finding her second derivative? I would like you guys to practice with this. And then, of course, my notes on limits at infinity is right here. There are the definitions and also the theorems affiliated with it, so that way you don't have to copy it down. It's already just typed up and ready to go. I would rather have you guys kind of work on the examples, example 1, example 2, example 3, 4, 5, 6, 7, and then just make sure you read this part. All right, so then with that said, let's go and turn our attention over here to question number 18 and have you guys kind of go along with this with the video. If you will want, you can go ahead and pause it and answer the following questions. Number 60 is a really good one because it talks about extrema, intercepts, asymptote, and how to sketch this. Now, I taught you guys how to sketch some of these on the last day before we left, Tuesday, so you're welcome to do that. And also, don't forget your week 15 Wednesday AP College Board assessment because that is due next Tuesday. You don't want to wait till the very last minute. You want to make sure you're pacing yourself. That's kind of like the big thing with this class is when you're taking a lot of AP classes, you really do have to pace yourself. And if I give you the additional time to do it, make sure you do it on the day that it is assigned, or else a lot of times you kind of push it to the end and you kind of forget. So let's go ahead and take a look at this. I also have a link to the video itself. So if at any time you want to check your answer, you're welcome to do that. That link is also on your guided notes. And so then with that said, I'm going to go ahead and kind of just get started with you guys on the guided notes itself for the link. I'm going to go ahead and just play the video for number 60 so that way you guys can kind of go over this one and have that readily available. Okay, so then with that said, I'm going to put them in theater mode. And just follow along. All right, you guys. So at this point, you should have your answers for this question for number 60. And so hopefully that helps with the curve sketching question. If you need to watch the video again, you do have that available um, on your guided notes. All right, I will see you guys next time. Stay safe and healthy. Take care.